China unveils ambitious blueprint for next-generation supersonic jet to outpace Concorde by 2025. Date: March 31, 2025. Event Summary. On March 29, 2025, China's state-owned aerospace manufacturer Comac unveiled its ambitious project for the next-generation supersonic jet named the C949. This groundbreaking initiative aims to surpass the iconic Concorde, which was retired in 2003, by achieving a speed of 1.6 Mach and an impressive range of 11,000 kilometers (6,800 miles). This announcement marks a significant step in the renewed global interest in supersonic travel, positioning China as a formidable player in the aerospace industry. Key features and innovations of the C949. The C949 is designed not only to improve speed and range but also to address the long-standing issue of noise associated with supersonic travel. Here are the key features and innovations. 1. Speed and range. The aircraft is designed to cruise at 1.6 Mach, which is faster than many contemporary jets, and has a range that exceeds the Concorde's by 50%. This allows for potential non-stop flights between major cities such as London and Kuala Lumpur. 2. Noise reduction. One of the most critical advancements in the C949 is its capability to produce a quieter sonic boom. The targeted noise level is 83.9 decibels, comparable to that of a hairdryer. This significant reduction is expected to help overcome regulatory barriers that have historically restricted overland supersonic flights due to noise complaints. 3. Innovative design. The C949 features a shape-shifting fuselage with a unique reverse camber midsection. This design is intended to mitigate shock waves, thereby reducing the intensity of sonic booms. The nose of the aircraft is elongated to help break up shock waves, creating a smoother sound profile. For passenger capacity, the aircraft is expected to accommodate approximately 168 passengers, which is more than the Concorde's maximum capacity of 128. This increase in capacity could make supersonic travel more economically viable. Competitive landscape. China's entry into the supersonic aviation market introduces a new level of competition, particularly against companies in the United States. Notable competitors include Boom Supersonic. This US-based company is developing the XB-1 prototype, which has already completed successful test flights. NASA and Lockheed Martin. Their X-59 project aims to achieve a sonic boom level of just 75 decibels, potentially setting new standards for supersonic travel. The C949's development could significantly influence global aviation standards, especially if it successfully navigates the complex regulatory landscape surrounding supersonic flights. Timeline and future plans. The C949 project is part of Comac's broader strategy, which aims to launch several key aircraft by 2049, coinciding with the centennial of the People's Republic of China. Other ambitious projects include the C929, a twin-aisle aircraft to compete with Boeing's 787 scheduled for launch by 2027. The C939, a 400-seat aircraft aimed at the Boeing 777X market, expected to debut by 2039. Regulatory and market implications. The development of the C949 comes at a time when there is a revived interest in supersonic travel, which had waned following the Concorde's retirement after a tragic crash in 2000. The focus on reducing noise levels is crucial for gaining regulatory approval and public acceptance, particularly for overland flights. Analysts estimate that the market for supersonic travel could reach 45 million passengers annually, representing approximately 1% of total global air traffic. If successful, the C949 could not only revolutionize air travel but also redefine the competitive dynamics of the aerospace industry. Conclusion. China's C949 project signifies a bold leap forward in aviation technology with the potential to reshape the future of air travel. As the world watches this development unfold, the implications for commercial aviation, regulatory frameworks, and international competition are profound. The C949 aims not just to revive supersonic flight but also to establish China as a leader in the aerospace industry, challenging established norms and competitors in the process. Sources: 1. South China Morning Post / www.scmp.com/news/China/science/article/3304082/ Comac C949 China unveils quiet supersonic jet 50 longer range Concorde. 2. Yahoo News / www.yahoo.com/news/China joins supersonic race plans 125652319.html. 3. Interesting Engineering / interestingengineering.com/transportation/China's supersonic jet Concorde. The announcement of China's C949 supersonic jet represents a significant step in the aerospace industry and reveals several counterintuitive aspects about the future of supersonic travel. Here are some of those insights. 1. Technological leap versus historical challenges. While the C949 is designed to be quieter and more efficient than the Concorde, which faced significant regulatory barriers due to its sonic booms, a common assumption is that technological advancements would automatically lead to regulatory acceptance. However, even with the C949's promised 83.9 decibels of noise, comparable to a hairdryer, overland flights may still face scrutiny. This suggests that even with superior technology, regulatory frameworks may lag behind innovation, highlighting a disconnect between technological capability and legal acceptance. 2. China's competitive strategy. The C949's development is part of a broader strategy for China to establish itself as a key player in the global aerospace market, particularly in a field historically dominated by Western companies. It is counterintuitive to think that a country that has been criticized for its technological theft and military ambitions could also lead in a high-tech civilian domain like supersonic travel. China's commitment to supersonic technology could reshape perceptions of its capabilities, illustrating that it is not merely a follower in innovation but an emerging leader. 3. Market demand versus feasibility. There is an expectation that supersonic travel will attract significant consumer interest, with estimates suggesting that it could handle 45 million passengers annually. However, the reality of consumer preferences for air travel often focuses on cost and accessibility rather than speed alone. The assumption that affluent travelers will flock to supersonic jets despite potentially higher ticket prices may not align with market behavior. This raises questions about the viability of the C949's business model and whether the anticipated demand will materialize as expected. For design innovations and practical limitations, the C949 is touted for its innovative design features such as a shape-shifting fuselage and a reverse camber midsection to mitigate sonic booms. However, there is a counterintuitive aspect concerning the complexity and cost of such advanced engineering. The notion that these innovations will seamlessly translate into operational efficiency and safety could overlook the challenges of integrating new technologies into existing aviation infrastructures and regulations. 5. International relations and perceptions. China's foray into supersonic technology is likely to heighten tensions regarding technological competition, particularly with the U.S. Given the potential dual-use nature of supersonic technology for military purposes, the assumption that technological advancements will foster cooperation in aviation may be misplaced. The entry of China into this arena may instead exacerbate fears about military applications, leading to a more competitive and potentially adversarial international atmosphere. 6. Environmental considerations. Although the C949 aims to reduce noise pollution, the environmental impact of supersonic travel, particularly concerning fuel consumption and emissions, remains a critical issue. The expectation that quieter jets will be welcomed without addressing their carbon footprint could be misleading. This reflects a broader trend in aviation where environmental sustainability is becoming a significant factor, potentially complicating the acceptance of new supersonic aircraft despite technological advancements. 7. Legacy of the Concorde. The C949's success is often compared to the Concorde, yet there is a paradox in this historical context. The Concorde was celebrated for its speed but ultimately fell out of favor due to safety concerns and economic viability. The assumption that a new supersonic jet will automatically overcome the legacy issues of its predecessor fails to consider the lasting impact of public perception and historical precedent on consumer confidence. In summary, while the C949 project embodies a bold vision for the future of air travel, several counterintuitive dynamics ranging from regulatory hurdles and market demand to international relations and environmental impact highlight the complexities that lie ahead for supersonic aviation. The report on China unveiling its ambitious plan for the next-generation supersonic jet, the C949, includes several significant features and innovations that many readers might overlook. Here are some of these aspects along with explanations of their significance. 1. Shapeshifting fuselage and sonic boom mitigation. Key detail: the C949's unique design includes a reverse camber midsection that allows the aircraft to mitigate shock waves, leading to significantly reduced sonic booms. Significance: this innovation is crucial because it addresses a major barrier that has historically limited the use of supersonic jets: regulatory restrictions on overland flights due to noise complaints. By potentially allowing overland travel, the C949 could open up new markets for supersonic aviation, fundamentally changing how air travel is perceived and utilized. 2. Extended range and passenger capacity. Key detail: the C949 is designed to have a range of 11,000 kilometers, approximately 6,800 miles, far surpassing the Concorde's range of 7,200 kilometers, 4,500 miles, and can accommodate up to 168 passengers. Significance: the extended range enables non-stop flights between major global hubs, which can greatly enhance connectivity and reduce the need for layovers. The higher passenger capacity compared to the Concorde also means that the aircraft could be more commercially viable, catering to a broader market segment. 3. AI-powered fly-by-wire system. Key detail: the aircraft is expected to incorporate an artificial intelligence-powered fly-by-wire system that manages the aircraft's aerodynamic stability. Significance: the integration of AI and flight control systems represents a significant leap in aviation technology. It not only enhances safety by improving handling and response during complex flight conditions but also indicates a trend toward more automated and intelligent aircraft systems in the future. 4. Potential dual-use technology concerns. Key detail: the advancements in supersonic technology raise concerns about possible military applications given the dual-use nature of such technologies. Significance: this aspect highlights geopolitical implications. As China advances in aerospace technology, it may shift the balance of power in military aviation, prompting responses from other nations and potentially increasing global tensions related to technological competition. 5. Market implications and competitive landscape. Key detail: the C949 is part of a larger race in the aviation industry, with competitors like Boom Supersonic and NASA's X-59 also developing their own supersonic jets. Significance: understanding the competitive landscape is crucial as it can influence pricing, technological advancements, and regulatory changes in the aviation industry. The outcome of this competition may set new standards for safety, efficiency, and environmental concerns in aviation, impacting not just supersonic travel but the entire industry. 6. Regulatory landscape and overcoming barriers. Key detail: the aircraft's design aims to meet regulatory standards that have previously hampered supersonic travel due to noise restrictions. Significance: this presents a potential shift in the regulatory landscape surrounding aviation. If the C949 can prove its noise reduction capabilities, it could lead to new regulations that permit overland supersonic flights, fundamentally altering air travel norms and expanding market opportunities. 7. Long-term strategic vision. Key detail: Comac plans to introduce several key aircraft models by 2049, including the C949, as part of a centennial vision for the People's Republic of China. Significance: this long-term strategy indicates a commitment to becoming a leading global player in aerospace. It reflects a broader trend of nations investing in advanced technologies to secure economic and strategic advantages influencing global trade and political relationships. 8. Environmental considerations. Key detail: the C949 is engineered to operate more quietly and potentially more efficiently than its predecessors. Significance: in an era of increasing awareness about environmental impacts, the C949's design could set a precedent for future aircraft. Balancing the need for speed with sustainable practices. This could influence public perception and regulatory policies regarding aircraft emissions and noise pollution. Conclusion: the significance of the C949 project extends beyond its technical specifications. It embodies China's ambition to lead in the aviation industry while addressing historical challenges associated with supersonic travel. The careful consideration of noise reduction, passenger capacity, AI integration, and geopolitical implications are vital details that could reshape the future of air travel and international relations. As these developments unfold, watching how China navigates the regulatory environment and competes with established aerospace powers will be crucial for understanding the trajectory of global aviation. 1. Technical innovations and design features. The C949 is poised to introduce groundbreaking innovations in supersonic aviation, such as its shape-shifting fuselage and reverse camber midsection, which are designed to reduce sonic booms significantly. The targeted noise reduction to 83.9 decibels, comparable to a hairdryer, represents a drastic improvement over the Concorde's 105 decibels. This technological advancement aims to address regulatory challenges that have historically hindered supersonic overland flights, thereby expanding the operational scope of supersonic jets. 2. Competitive landscape and global aviation impact. China's entry into the supersonic market with the C949 intensifies competition, particularly with established players like Boom Supersonic and NASA's X-59. This rivalry could lead to a redefinition of aviation standards and practices, potentially altering global air travel norms. The introduction of multiple supersonic projects signifies a renewed interest in the segment after decades of dormancy, suggesting that the next few years may witness significant advancements and innovations in commercial aviation. 3. Strategic goals and future plans. The C949 is part of a broader strategic vision by Comac, aiming for a series of aircraft launches by 2049, coinciding with the centennial of the People's Republic of China. This long-term strategy includes the introduction of the C929 and C939, targeting different market segments. The C949's development is not just about immediate commercial success but is also a significant step in establishing China's position as a global aerospace leader, reflecting national ambitions in technological advancement and self-reliance in high-tech industries. For regulatory and market implications, the successful development and deployment of the C949 could lead to significant shifts in regulatory frameworks regarding supersonic flight. Historically, sonic booms have posed considerable challenges to overland supersonic travel, but the C949's reduced noise profile may enable new regulations that allow for such flights. Moreover, the potential for supersonic travel to capture a market of approximately 45 million passengers annually opens up new economic opportunities, which could attract investment and further innovation in the aviation sector. 1. Concorde 1969–2003. The Concorde was a turbojet-powered supersonic passenger airliner that was a joint venture between British and French aerospace manufacturers. It could reach speeds of over Mach 2.04 and serve transatlantic routes, drastically reducing flight times. However, its operational costs, noise levels, and regulatory challenges limited its commercial viability, leading to its retirement in 2003. 2. Boeing 2707 1966–1971. The Boeing 2707 was a proposed supersonic transport aircraft that aimed to compete with the Concorde and the Soviet Tu-144. It was designed to carry 250 to 300 passengers at speeds of Mach 2.7. However, the project faced numerous challenges, including escalating costs, concerns over environmental impact, and shifting market demands, leading to its cancellation in 1971. 3. SST Supersonic Transport Program 1970s. The United States government initiated the SST program in the 1970s to develop a commercial supersonic airliner. The goal was to create an aircraft that could travel at Mach 2.4. But the project faced significant public opposition due to noise and environmental concerns. Ultimately, the program was terminated in 1971 with the environmental impact and economic feasibility cited as major reasons for its cancellation. China's unveiling of the C949, a next-generation supersonic jet, marks a pivotal moment in aviation history and sets the stage for a competitive landscape that could redefine air travel. With ambitious targets to surpass the Concorde by 2025, the C949 is not just a technological marvel but also a strategic move in the global aerospace arena. Predictions for the future of supersonic travel. 1. Increased global competition. As China enters the supersonic race with the C949, competition will intensify. Companies like Boom Supersonic and NASA's Lockheed Martin are also developing their aircraft aiming for quieter and more efficient designs. This competition will likely stimulate innovation, leading to advancements in materials, aerodynamics, and propulsion systems. By the late 2020s, we could see multiple contenders vying for market shares in the supersonic travel industry. 2. Regulatory changes. The C949's design focuses on significantly reducing sonic booms, which has historically been a barrier to overland supersonic flights. If successful, this could prompt regulatory bodies worldwide to reconsider their restrictions on supersonic travel. By the early 2030s, we may witness a gradual lifting of bans on overland flights, expanding the operational range of supersonic jets and increasing their viability in commercial aviation. 3. Market growth and demand. The global demand for faster air travel is projected to grow, particularly among business travelers and affluent tourists. The introduction of the C949 and similar aircraft could lead to an estimated 45 million annual supersonic passengers by 2030, representing about 1% of the total air travel market. This surge in demand will likely encourage airlines to invest in supersonic fleets, making air travel more accessible to a broader audience. 4. Technological innovations. The C949 showcases advanced technologies such as its shape-shifting fuselage and AI-powered fly-by-wire systems. As these technologies mature, we can expect further innovations in aerodynamics and energy efficiency across the industry. By the mid-2030s, we may see new supersonic jets equipped with hybrid propulsion systems integrating sustainable aviation fuels or electric components to reduce carbon footprints. 5. Environmental considerations. As concerns over climate change and environmental sustainability grow, the aviation industry will face increasing scrutiny. The C949's quieter operation is a step in the right direction, but further advancements will be necessary to meet future environmental standards. By 2040, we may see a push for supersonic aircraft to significantly lower greenhouse gas emissions, potentially utilizing alternative fuels or more efficient propulsion technologies. 6. Strategic implications. China's advancements in supersonic technology may have geopolitical implications, particularly regarding military applications. The dual-use nature of such technology could lead to heightened tensions and an arms race in aeronautics. By 2030, nations may prioritize the development of supersonic military capabilities, leading to strategic partnerships or rivalries centered around aerospace advancements. 7. Consumer experience transformation. As airlines adopt supersonic travel, passenger experiences will evolve. The C949 aims for a capacity of 168 passengers with a focus on comfort and speed. By 2035, we could see a shift in airline service models, with enhanced amenities and personalized in-flight experiences becoming standard in premium offerings. The emphasis on luxury and efficiency will redefine expectations for air travel. 8. Infrastructure developments. With the revival of supersonic flights, airports may need to adapt their infrastructure to accommodate these new aircraft. By 2030, we could see the introduction of specialized terminals and runways designed for supersonic jets, enhancing operational efficiency and passenger convenience. Conclusion. The introduction of the C949 represents not just a leap in technological achievement but a significant turning point for the future of aviation. As global competition heats up, regulatory landscapes shift, and consumer demands evolve, the next decade will be crucial for the establishment of a sustainable and thriving supersonic travel market. By 2040, we may witness a transformed aviation landscape where supersonic jets are a common sight in the skies, significantly impacting travel culture and industry standards.